All right, so what that last little exercise showed us is that XOR, in XOR, parity, is hard, it's exponential. But that kind of provides us a little bit of a hint, right? We know that XOR is hard, and we know that OR is easy, at least in terms of the number of nodes you need, right? But we don't know going in what a particular function is, so we never know whether the decision tree that we're going to have to build is going to be an easy one, that is something linear, say, or a hard one, something that's exponential. So this brings me to a key question that I want to ask, which is exactly how expressive is a decision tree? And this is what I really mean by this. Not just what kind of functions can it represent, but if we're going to be searching over all possible decision trees in order to find the right one, how many decision trees do we have to worry about to look at? So let's go back and take the XOR case again and just speak more generally. Let's imagine that we once again have n attributes. Here's my question to you, Michael. How many decision trees are there? And look, I'm going to make it easy for you, Michael. They're not just attributes, they're Boolean attributes.
Thanks.
Okay? And they're not just Boolean attributes, but the output is also Boolean. Got it?
Sure. But how many trees? So it's I'm going to go with a lot.
Okay. A lot. Define a lot.
Define a lot. So, all right. Well, there's n choices for which node to split on first.
Yeah.
And then for each of those, there's n minus 1 to split on next. So I feel like that could be an n factorial kind of thing.
Maybe. I like that.
And then even after we've done all that, then we have an exponential number of leaves, and for each of those leaves we could fill in either true or false. So it's going to be exponential in that too.
So let me see if I got that right. So you said we have to pick each attribute at every level. And so you see something that you think is probably going to be, some kind of combinatorial question here. So let's say n factorial. And that's going to just build the nodes. That's just the nodes. But once you have the nodes, you still have to figure out the answers. And so this is exponential because factorial is exponential. And this is also exponential. So let's see if we can write that down. So let me propose a way to think about this, Michael. You're exactly right the way you're thinking. So let's see if we can be a little bit more concrete about it. So we have Boolean inputs and we have Boolean outputs. So this is just like AND, it's just like OR, it's just like XOR. So whenever we're dealing with Boolean functions, we can write down a truth table. So let's think about what the truth table looks like in this case. Right? So let's look at the truth table. So what a truth table will give me is, for the way a truth table normally works is you write out each of the attributes. So attribute 1, attribute 2, attribute 3, and ... and there's n of those. Right? We did this a little earlier when we did our decision tree, when we were trying to figure out whether I was on a hot date or not. And then you have some kind of output or answer. So each of these attributes could take on true or false. So one kind of input that we might get would be, say, all trues. Right? But we also might get all trues except for one false at the end. Or maybe the first one's false and all the rest of them are true, and so on and so forth. And each one of those possibilities is another row in our table. And that just can go on for we don't know how long. So we have any number of rows here, and my question to you is, how many rows? Go.